Okay, so once you watch the first two videos, now you understand where do we get the derivative of cosine, how can we find it, and the derivative of sine and the derivative of cosine. Also, you already noticed that you can find the other derivatives of the standard trigonometric functions using the quotient rule that you already know and the power rule that you know. So let's start and let's use these two derivatives that we have, the derivative of sine and the derivative of cosine, to solve the first example. This is example number 1 that says that you have to calculate the second derivative of f of x if f of x equals x cosine of x. So this is a product. We have two equations. X is the first one and cosine of x is the second one. So by the product rule, the first derivative will be the first one times the derivative of the second one, the derivative of cosine of x, plus the second one, cosine of x, times the derivative of the first one, which will be the derivative of cosine. We have it here, negative sign, so negative x sine of x. The derivative of x is equals 1, so plus cosine of x. And that's the answer. Cosine of x minus x sine of x. And that's the first one. Okay, let's do now the second derivative. The second derivative of x will be the derivative of cosine, which equals negative sine of x. And we have a product again. So here we will have the first one, x, times the derivative of the second one, the derivative of sine equals cosine of x, plus the second one, sine of x, and the derivative of the first one, which is x, the derivative of x is 1. So the final answer for this one will be negative sine of x minus x cosine of x minus sine of x, which equals negative 2 sine of x minus x cosine of x. And that's the answer, and that's what they were asking for. Okay, may I go on? That was example number 1. Example number 2 of the book, let me erase all this. Example number 2 of the book, it's the proof of finding the derivative of tangent, which is something that we already saw on the video. So I won't solve example number 2, but I will solve example number 3. On example number 3, what you have to find, now we have tangent and secant, which are not here. Let me write them here. So let's continue, and now I'm going to solve for you example number 3. On example number 3, you have to find the tangent line to the graph of y, which equals tangent of theta times secant of theta at the point theta, which equals pi over 4. That's why I have these two values here, secant and tangent, because I'm going to use it. So remember that if you need to find the tangent line to the graph, then you need to find the derivative and plug in the value that they gave us in the derivative, and then you also need to plug in that value in the original equation to use the point slope form that you already know. So let's start by finding the derivative, y prime. We have a product, so it's going to be the first one, tangent of theta, times the derivative of the second one, secant prime of theta, plus the second one, secant of theta, times the derivative of the first one, tangent prime of theta. I add for you the two equations here, the two derivatives here, so we can use them. So that means that it's going to be tangent of theta, the derivative of secant, it's going to be secant tangent, so times secant times tangent of theta, okay, plus secant of theta, and the derivative of tangent, which equals secant square of theta. That means that this is going to be secant of theta, tangent square of theta, plus secant cube of theta. Now I'm going to plug in the values. y prime of pi over 4, which is my point where I want to find it, and I will plug in secant of pi over 4, which is going to be square root of 2, times tangent square, which is 1, plus secant cube, which is square root of 2, and that's going to be cube. Yes? So at the end, we will have 3 times square root of 2 plus, no, 2 square root of 2 plus 1. So this is going to be 3 square root of 2. Then I will plug in my pi over 4 in my y, which is going to be tangent, which is 1 times secant square root of 2. So the answer is square root of 2. Now I will plug in those two values, which will give me y minus y initial, which is the square root of 2, equals the slope 3 times square root of 2 times theta minus pi over 4, which is the original value. And that's it. So based on these 3 videos, you're going to be ready to do the homework for today, all these problems. Good luck.